If you want to use LINQ to datasets, that is with the typed or untyped datasets, there really are the two different scenarios. There's linked to typed datasets. That's really just working with linked objects because you have a class that represents your data. Or linked to untyped datasets, which is a lot more effort. Linked to typed datasets is like linked objects. There's no difference. Linked to untyped datasets requires extra effort because you're really querying over a collection of data row objects in a data table. The problem is, data table doesn't implement IEnumerable, and you can't query unless the object you're querying implements IEnumerable, so this is a problem. Also, fields in an untyped data row aren't known until runtime. So that, too, lends itself a problem because there's no way you can get IntelliSense on fields in an untyped data row because there's no way at design time you can know what's in there. Let's start then with the easier case, using LINQ to typed datasets. Like I said, this is just like working with LINQ to objects. The table adapter fills in the data, and the schema is known at design time because the typed dataset is a class that represents your data. Let's try an example that uses LINQ to typed datasets, and you'll see it's really not much different than what you've seen already. In the sample project, I've already added a Northwind dataset, which I created by adding a dataset item to the project and then dragging on the products and categories tables from the Northwind SQL Server database example. Now, there are reasons to use a typed dataset. There's reasons not to use a typed dataset. For whatever, it's older technology, and it's really easier to use the new data context. But you might have these lying about, and you might want to program against them using LINQ. Well, since it's just a collection of objects and properties, it's the same as using LINQ to any other kind of object. I'll click the sample button, and it takes us into our code. And here, we will start by creating an instance of that Northwind dataset object. Now, in this case, once you create the dataset, you also need to create instances of the various table adapters so that we can fill data tables. So we'll create the instances of those products table adapters and categories table adapters. And now we'll use each of them to fill one of the data tables within our Northwind dataset. There we go. Once we have the data filled in, it's just a matter of using LINQ over objects. So in this case, we'll say from product in Northwind data dot products, that gets us all the product information, we'll iterate through it, order by category ID, then product name, where the product dot unit price is greater than 50, so we'll only get items costing more than $50, and we'll create an anonymous type, which includes 3 fields, product name, unit price, and category name. And for the category name, we're using the categories row property of our product to get back, well, to work backwards up the relations to the category table, and for that particular category, get the category name. We'll display the results in a list, and it looks like you might expect. We get all the items that cost more than $50 and get their category name as well. So LINQ to type datasets is easy. It's just like working with LINQ over any other kind of object. LINQ to untyped or standard datasets, however, probably not so easy. Using LINQ to untyped datasets is possible, and obviously the teams at Microsoft made a lot of effort to make this happen, but it's a lot more effort on your part as well. It's more complex than working with a typed dataset because you're not working with a collection of objects. Well, you are. It's just collections whose schema you don't know. The problem is, first of all, you're querying over a collection of data row objects in a data table, not a specific type of data row in a specific type of data table, just the plain old data row in a data table. And data table doesn't even implement IEnumerable, so how can you work around this? Extension methods solve this problem. Remember, an extension method allows one class to extend the behavior of another. So, the LINQ namespace includes an extension method for the data table class, which doesn't change at all. There's an asEnumerable method, which is an extension method on the data table class, which allows us to retrieve the contents of the data table as an enumerable instance. So you can then query it. So we'll need to call the asEnumerable method of the data table before we can query it using LINQ. Also, the schema is unknown until runtime, so we need some sort of loose typing on field names and types. Now, the two languages handle this differently. Visual Basic uses a bang operator, and C# uses this syntax. Now, the reason I point this out, both for VB and for C# developers, is that this syntax also works similarly in Visual Basic. Visual Basic just has this cool bang operator, which it's had since the beginning of Visual Basic, that allows it to have loose typing on the names of elements of a collection. C# doesn't have this operator, so it requires you to use field, and then in angle brackets, the type of that field. VB would use just parentheses for that type, and then the field name as a string. Not nearly as neat as Visual Basic's bang operator, but either way, you get no IntelliSense. Obviously, there's no IntelliSense because at design time, you don't know the names of the fields. You just have to type them and hope you type them correctly. Let's try an example that demonstrates using LINQ to an untyped dataset. The Link to Datasets button takes us to an example which, well, provides LINQ over an untyped dataset. In this case, I'll walk into the procedure called fill dataset. And fill dataset just fills a dataset with a single data table. Notice there's nothing typed about this. It's all just standard dataset, data adapter, data table stuff. So we've got a new dataset. We have a data adapter getting a connection string from our web.config file and create a new SQL data adapter using select star from customers as our command text. And we'll fill our data set, creating a table named customers. And we return that data set back. So here we are, we've got a data set all filled in, and let's get the data table which corresponds to customers out of that data set. Of course, I just could have filled a data table. That would have been simpler. I could have skipped this line of code, but let's move on from there. So customer table is a standard data table. Data table doesn't implement IEnumerable, so we have to do something so we can use this query technology on it. And the answer is to use the asEnumerable method, which takes the data table and extends it. It's a new method. They didn't change the data table class. What they did was create an extension method for the data table class. It's defined in some other class somewhere else. We don't care. But it comes to us as a method of the data table class. So that's how we can use querying technology on that data table. But now, how do we indicate the fields? Well, we don't know at design time what the fields are in this data table. Therefore, we have to use a new syntax. In this case, we have a field property, which is a generic property. So c.field, we need to specify the type, which is string. Once we know the field type, it's string, we pass as a parameter the name of the field. In this case, country as a string. So we don't get any early IntelliSense on this, no early binding. We just have to know the name of the field. There's no compile time checking on that field name, so you could type it wrong completely and the compiler wouldn't know. It'd be a runtime error. We compare that to USA, and again we select new, which gives us an anonymous type, and we'll create a new type which has customer ID and contact name in it. And for each of those, we'll retrieve the value of a field in the data set. In this case, we want to retrieve customer ID and contact name. Both of those are strings, so we say c.field of string, then pass the name of the field we want to retrieve, customer ID or contact name, as a string. So using those two tricks, using the asEnumerable method to give us an enumerable version of the data table, and then using this syntax with the generic field type, where you supply the field name, allows you to retrieve information from this standard untyped dataset and use it with LINQ. As you'll see, we're very happily able to retrieve information from that standard dataset using a LINQ query and those two extra little tricks. In building applications, XML provides another common data source. The LINQ goal is to make it easier for you to work with XML data using the new XDocument class. Now, you could always work with XML data using the XML document class, but that was a lot more work. The XDocument class and its friends, XElement, XAttribute, XComment, and so on, make life way easier when working with XML content, especially when you create XML content. In addition, these classes, XDocument, XElement, and so on, are the classes you'll receive when you use LINQ to query XML data. The LINQ query will hand back to you a collection of X elements or X attributes or whatever. Now, Visual Basic in this area adds some extra features. C# folks, you're on your own. You'll see examples, but Visual Basic does make it easier. It embeds XML data natively within code, so you don't even have to use these classes to build XML content. C# developers will have to build the XML content manually using new instances of the XDocument, XElement, and so on. Visual Basic can just embed XML natively in the code stream. In addition, Visual Basic provides schema-based IntelliSense. If there's schema available, you'll get IntelliSense against your XML as you write the code. In addition, it has descendant and attribute operators, that is, 3 dots and an @, making the code a little bit more readable than the corresponding C# code. There's nothing you can't do in C# that you can also do in VB. It's just that Visual Basic makes it a little easier using these new features that are LINQ to XML specific. We'll look at examples that show off creating, querying, and modifying XML content using language-specific features. To generate working with LINQ to XML, I'll click this sample button, and we'll start by creating an XML document for us to work with. This also shows off some new information that makes it easy to work with XML and LINQ together. The Create Document procedure here creates a new XDocument. Now in C#, this is the only way to do it, at least the only reasonable way to do it. In Visual Basic, you can use embedded XML to make this much easier. But in C#, this is the easiest way to create XML content. We start out by returning a new XDocument object. This object is new in Visual Studio 2008 and allows us to, well, embed in a hierarchy the actual content of the XML. It's easier than working with the XML document object because if you created content using XML document, you had to create nodes and append them, and you had all this code, and your code didn't look like the actual XML. Well, this does look like the actual XML with a little extra stuff thrown in. So we start by creating a new XDocument, and within that XDocument we have an XDeclaration, an XComment, and an XElement. Within the XElement we have a Departments element. Within the Departments element we have 2 department. Here's one element, and down here we have the other one. Within the department we have an attribute whose name is name and whose value is breads, and we also have 2 elements inside of it. We have an X element whose name is item that has a new X attribute, in other words, whose name is ID and whose value is B1, and it contains 3 sub-elements, name, price, and this empty element named new. We also have a second item here whose type is muffin and whose name is blueberry muffin, whose price is $3.99, and it also has an empty new element. In the second department, we have an attribute whose name is name and value is fruits. We have a new element inside of it whose name is item, and an attribute applied to that element, and 2 sub-elements. So this method generates the XML content that we'll need. Now C# is pretty cool about this. Let me stop. And show that when you type this stuff, C# indents it neatly for you. So if I came along here and created here a new X element, and I come here and start finishing it up, within here, oops, need a semicolon there. Within here, it indents it for me. Need a comma, not a semicolon. There we go. And if I put something inside here, like a new X attribute, and type the name, which will be some name, and the value, some value, it assumes I want another attribute at the same level, or if I come out here and just leave that, finishing that up, put a comma, and so on, they handle the indentation for me. So it's a great way, an easy way, to create XML content within your code. Let's get rid of this new stuff I added there, put things back the way it was. Let's run it again. Get back to where we were. We've created the document, and we come out of that. Doc now contains that XML content. You can even see it here. If I bring up the immediate window, I can print out the contents of that variable, and you can see there's the XML that we created. It would help if you memorize that XML for what's coming up next, but in any case, keep a copy nearby so you can refer to it as we look at the following code. I'd like to, well, first print out the entire contents of that doc, but now I'd like to retrieve items whose name is item, whose parent's name attribute is breads, that is, items within the breads department. Here's how you do it. You can write a LINQ query that does the work for you. From item, that's our iterator, in doc.descendants, and in quotes, item. That says, find me all the descendants of the root document element whose name is item. Well, we found all those items, but there's items that are in the wrong department. So we now want to say where item.parent.attribute, that is, go up a level and get an attribute named name equals breads. Of course, we need to cast that attribute as a string. It's an object otherwise. So we cast it as a string, compare it to breads, and for each of those, select the item. So we should get two items. There was Wonder Bread and Blueberry Muffin. And now for each of these, we're going to print out the item, which is the entire XML content of the node we found. Let's print those out. There should be two of them. There we go. And now to retrieve the text inside each element, we'll use the value property. The value property returns all the text inside the element concatenated together, which in our case will be Wonder Bread and its price, Blueberry Muffin and its price. You'll see that that is the value. There we are, Wonder Bread and its price, and Blueberry Muffin and its price. Okay, well that was interesting. Now let's retrieve sub-elements. To do that, we can go into each one. For each item in our collection, we'll retrieve item.element, goes one level beneath, finds the element named name, and gets the element. We'll convert that to a string and print out the value. The same thing for price. We'll go one level down, find the element named price, get its value, and display it. And you can see here when I've run the full thing, here's the XML content. Here were the matching elements. Here's the Wonder Bread element. Here's the muffin element. That's Blueberry Muffin. Down here, when I retrieve the text, we get all the text inside concatenated together. And finally, retrieving sub-elements, we get the name and the price displayed separately. So LINQ to XML provides an easy way to first create XML and then to query that XML looking for specific values. Sure, you could use XPath, but this is a lot easier. You can use LINQ queries to transform XML in a more straightforward manner than, well, anything would be more straightforward than using XSL transforms as far as I'm concerned. To do this, you combine new XElement instances with LINQ over XML query. As you'll see, you can, in your select clause, output whatever you want from this query. It's a pretty interesting technique. To make it easier, Visual Basic also provides embedded transformations using angle bracket %, just like ASP.NET does, that is replaceable tokens within the output. Let's look at an example that demonstrates how you can transform XML using LINQ in language-specific features. LINQ to XML works well in transforming XML because, if you remember, in LINQ, when you use a select clause, all you're doing is projecting the input data into a new output format. So it makes it easy to transform XML. I'll walk in here. We'll create the document just like we did in the last example. I'll display that document again. What I'd like to do is rearrange the output. I'd like to see an element named items. Within that element, I want to see 3 item elements, each one of which has an item name and a price attribute. So we're rotating the data a little bit into a different format. So first thing we're going to do is from item in doc.descendants, whose name is item, select item. So item right now, or items that is, should contain 3 bits of XML. Here are the 3 items: Wonder Bread, Blueberry Muffin, and Apple. So we've retrieved the original XML for those 3 items. Haven't transformed them yet. So here's what we're going to do. We're going to set our transformed content equal to a new X element named items. That creates the outer portion of the element. Now the content is going to be the results of running this LINQ to XML query. From item in item, so we'll loop through each item in turn. We'll select a new X element named item, so we'll get the element named item. And the contents of that element will be, well, a new attribute named item name. And to get that, we'll look at item, look for an element named name inside of it, and get its value. We also want an attribute named price. And to get that, we look at item.element named price inside of it and get its value. Well, that's all there is to it. This LINQ query will iterate through all of the items and do the work for us. In each case, create this output. It's just amazing. You look at this and it just works. We select as the output in our query this new format, which is an items element on the outside, 3 item elements, and for each one, attributes that contain the data. So we've transformed each item from this format to this format using a LINQ to XML query. You need to go run that again. Examine that code carefully so you understand how we got from this format to this format with just basically, well, I'll look again, I can't help myself, with just basically this single line of code. We could have used an XSL transform for this, but it's a lot easier, at least in my eyes, to use a LINQ query, which iterates through and uses the select clause to project the input into a new output format.